I will make a general presentation of the generics, and also I will make a presentation of how we'll work together, all right, during all these 14 weeks. All right. Let's start with course orientation. You have here welcome to the course and a welcome message from us, some very simple and
you are now muted.
Very simple information. Met your professor, so this is me. So guys, very important thing, all right? So if you are facing a problem during the course, or you have something important to communicate with me, please, you have here my email address. Contact me directly, right? And I will answer as soon as possible, okay? This is a, fastest way, to to get an answer to your specific question. All right, don't forget, this is my email address. You can contact me anytime. All right, there are expectations and responsibilities, general rule of etiquette. So please be polite with me. Be polite with your colleagues. All right, that are general rules. Okay. Those are your expectations regarding my work as a professor. Well, how to use centennials, because you are not on the students in the first year. You already have experience working with e-centennials, so I will go very fast over all these elements. All right, you have e-health, technical support, accessibility, how to use e-centennial for this course, so on and so on. We'll go in deep, a little bit in deep when we'll discuss about the outline of the course. Available learning supports, student handbook, all right, and the checklist. Okay. All right, course outline and evaluation. Very important is this course outline. No, we in general we don't record the session. Why? Because everything that we are discussing, except the general discussion, everything that we discuss will be in the file on eCentennial. All right. So instead of building a huge recording file, everything important for you guys will be in file on eCentennial, and you will be able to read it directly. All right. So compare with the previous semester, we change a little bit the outline. All right. What is important, very, very important for you is this book. Guys, the book that we are using is Christian Nagel, Professional C#.NET 2021 edition, okay? Released on September 2021, okay? And you should be able to find it online. Okay, try to find it online, guys. Okay. All right. Okay, so regarding evaluation, so how will what are the marks that you will get? Okay, so the weight of the marks. So we will run 5 labs. Labs doesn't mean homework. Okay, so each of these homework will weight 10% of the final grade. All right, so we have lab 1, 2, 3, 4, 5, and we have test number 1, 25% of the final grade, and test number 2, another 25% of the final grade. Okay, so already in your your table of content, so on the week number 1, you already have lab number 1, which is due at the end of week number 3, right, on 28th of January. All right, guys? Okay, so let's go over the outline. All right, today we'll start with generics, right? Generics method, extension method, what is boxing, unboxing, structured generic, extension, type constraint. Okay, so this is what we'll discuss today. Next 2 weeks, so week 2 and week 3, we'll jump to data structure with lists, stacks, queues, and after that we'll go with dictionaries, sets, hash table, sorted dictionaries, and so on and so on. Okay? Delegate, observer, and so on and so on. So everything is here on your course outline, all right? Careful, this course outline is different compared with the last semester. So be careful about that, okay? And again, very important thing, very important thing is a book. The book now is the last version of Christian Nagel, Professional C# 2021 edition, September, release on September 2021, okay? Good. Going back. All right, so we discussed about orientation, course outline, we can find it here. Week number, okay, so this is week number 1. The other weeks, as we can see, are hidden. All right, so I don't want, again, to go over it. Just stay focused on what I'm giving you, okay? All right. Let's do a little bit of a short startup, you know. All right. All right. Programming tree. Again, this is my contact. All right. You can find it online on eCentennial. Again, for any problem, please contact me. So what we try to achieve here, right? So the program is giving you knowledge and skill that will be useful in your future career, provide you with skills and abilities specific to your chosen career, skills and ability helpful to your future life outside of work, help you to understand your career option, right? This is very important, right? So if you want to ask me what you should do in a specific area, if you have to learn C#, sure, you have to learn it. But maybe you try to choose a different path in your career, you know, database or security or whatever. Help you understand your career option, develop your writing skills, develop your speaking skills, develop your math skills, develop your ability to solve problems, develop your computer skills, help you understand further education opportunities. Okay? So that are general outcome of this course and any other course. What are the major concepts? that will attack during this course. Generics, introduction data structures, delegate, event handling, asynchronous programming and parallel programming, graphic user interface with Windows Presentation Foundation, advanced graphic user interface programming, entity framework core, and the last chapter, but a very important one, a very modern one, machine learning framework. Okay, so we'll start to learn and run machine learning APIs. Machine learning actually will build up machine learning programs. Evaluation, again, I hope you remember 5 assignments. Each of the assignments, homework assignments, 10%, so in total 50%. Test 1, 25%, test 2, 25%, okay? Yeah, very important thing, because I forgot. So guys, try all the time to be in time, all right? Do not delay your submission. Okay, do not delay your submission, because 1 day of delay is 20%. After 1 week, I'm not receiving your, doesn't matter, you know, except you have a medical situation, then that is a different thing. But I need, you know, the certificate from the doctor for that. Okay, so please be on time all the time with your submissions. Test books. Again, Nagel, last edition, September 2021, okay? Also, very important, Microsoft documentation, plus our slides that we can find them on eCentennial, some demonstration that I will run it on during our lab time. Also, you can use Google, YouTube to find, you know, similar solution or similar exercises, okay? Your responsibilities, regular and punctual, must have Visual Studio ready, all right? Don't forget, I need Visual Studio. You need, you know, install at least 2019. All right, a good idea to install 2021 and to run it. Also, what you have to do, you have to complete all the assignments, require reading before the class. If you can, read, you know, the material. If you are absent, sure, you are responsible for the missing material. All right, very important, no plagiarism, all right? So, guys, I'm very open for any kind of solution. I know that this course is a very hard course, all right? So, I'm, let's name it, I'm encourage you to work in groups. But working in groups doesn't mean each of you should present me the same code. Okay, so be very careful about that. If I will find 2 submissions with the same code, I will mark it 0. All right, so actually not 0, 1. I'll mark it 1. So be very careful with that. All right, even if you work in group, trying to jiggle a little bit with the code, try make it personal. All right, working in groups, it's great because you learn actually programming from your colleagues. Okay, not only here 2 hours in a week, and also that will help you a lot to understand other people way of thinking, other people way of building programs. Okay, so I'm encouraging you to work in groups, but do not send me the same code, 2 people having the same code. right? Because in the moment when I start reading the code, I'm okay. I already saw that in another place where take a look. It's here, all right? And I will mark both 0. All right. So related plagiarism, okay? From time to time, I will ask you to verify, all right? I will ask you, all right, try to rebuild this application because maybe you can change something. We can make it a little bit nicer, okay? All right. So that are general things. So guys, if you have any questions for me after this short presentation, if you have any questions for me. Okay, looks like there are no questions. Okay, now, week number 1, generics, introduction. Overview. All right, so that are a few elements. Okay, so this is a theory, generic, type constraint, and extension methods. So guys, what you have to do, you have here a zip file with examples, all right? Download it and check the examples, all right? Here you have the theory associated with this module. Right, generic structure, boxing, unboxing, generic classes, some videos, generic method, generic interfaces, and short piece of code here. Type constraint, multiple constraint, and that's it. Okay. So this is a theory, guys. I'm encouraging you to read the chapter regarding generics from the book. Okay, please do it. And another very important thing, let's start on lab number 1. Okay, so you have to click on lab number 1. You have to download it in your computer. All right. And this is a lab. Okay. So that will be your first assignment. It's lab number 1 and is due date on January 28th, in 2 weeks. So I very encourage you to start already working on it because it's hard. Okay, please do it. There are 3 questions. The first question is asking you to use example to illustrate the difference between array and linked list. Use example to note features, stack, and queues. Use an example to demonstrate a type constraint. All right, so that are some marks here. Question number 2, implement an extension method for class string builder to count the number of words in a string builder object. All right, so this is a very simple question. So we just give 2 marks for this. And number 3, implement a .NET. Okay. Can we ask for a review by mail about the lab before? Sure. But guys, don't send me, so it should be punctual questions, all right? So don't send me all the assignment, all right? Check it, and after that you'll submit it, all right? I'm checking it. No. Ask me about punctual things, all right? I don't understand this aspect. I don't understand how to make a queue for this object, all right? So something like that. Don't ask me, okay, check please all the submission. Doesn't, because consider there are, I have a lot of students. If I would do that, everyone will get A+, all right? So this is the reason that I'm asking you, try to work as in groups. Okay, so try to make small groups, few guys, based on time zone or based on whatever, working with your friends eventually. Okay, because it's easier to check the material. There are, on the top of what we are posting here, there are tons of materials online. So try to use those material. All right, this is question number 3, which is also a lot of marks because it's a hard question. You need to build up a Windows form application or whatever. And you have also the database. All right, so you have the database there. Take a look. This is a database. All right, and answer the question. Okay. Choose appropriate data structure to organize the data. We should be able to add a new element, delete a specific data, implement a generic search method. Okay, so this is what you have to do. Okay, now everyone, it's okay, guys? So do I have your understanding regarding what you have to do in 2 weeks? Because this is very important. Guys, everyone is okay, I suppose, right? So I'm getting just 1 yes in this moment.
Sounds good, Professor.
Yeah, all right. Okay, good, perfect. All right, good. So start working, guys. Honestly, it's hard, all right? Start working and finish it on time, submit it, run, do the submission. Let me check if everything is okay. Assessments, it's open. Yes.
Sorry,
Yes.
so just one question I have with that
Sure,
question 3.
please.
Appropriate data structure is basically just how do I hold what I'm reading from the medals.csv, right?
Would you please repeat? I wasn't.
So it says choose appropriate data structure. So of the information that I read from the medals.csv. So that's just how I hold the information once I've read it into my program, right? Okay.
Yeah. Yeah. So, other questions, guys?
Will we be going over something like the linear search algorithm at all, or is that assumed pre-knowledge?
You should be able to know this kind of search algorithm. Also, from what I remember, we have some exercises that implement this kind of. Okay. So
perfect. If we have something that does something similar, that's
yeah. We are using Bubble. Yeah. All right. So Yeah, so if there are no questions, we'll go ahead with the first week, the first presentation. All right, so all right. So guys, again, if you have any questions, please let me know. All right. So okay. So all right. Looks like everything is okay. Okay, so guys, what is your knowledge about generics? Did you ever heard about generics? There is someone that used generics before? Hmm? Question. Exactly. All right. So this is a very good question. A very good answer. I'm sorry. Um, so exactly. So this is the idea. All right. So if we work with specific structures, right, we have to declare, all right, and we have to build up an application that match that specific type. So we in any kind of language, programming language, they try to find a solution. All right, why should I um, you know um, um, why I'm not able to write a kind of abstract code, all right, and after that, to that piece of code to be able to be used for any kind of data. So this is a basic idea of generics, right? So as a general idea, generic allow writing more abstract code. Whatever the program does, he doesn't have to worry about the concrete type of his data structure, right? Or on his method that he's using. Um, this is not only is not all. Generics allow writing such a code in a type-safe manner, right? In languages like C Sharp, for example, on every value is a descendant of the object type. It is possible, even without generic, to write a piece of code which abstracts the type of value stored in a data structure. Right? Let's run a very simple example. Um, so here is a simple. So I will run a simple piece of code. Right? So it's a simple piece of code implementing the stack data structure. Right? All right. So um, now um, having this class, we can compile and successfully run the code like this. Right? And we can define the class person like that. Guys, not necessary to take notes, all right? Not necessary to take, because everything, I will post everything on eCentennial. So you'll be able to see the document there, all right? With all these examples. All right, guys? No worry about, taking notes. Okay, so looks like we solve the problem. We just create a stack implementation which is independent of the type of object which is stored inside it. But this comes with a problem. Our solution is actually an error. It's enough to switch in the code sample the two line which invoke of the pop method to get a program which compile without warning and actually is not type safe, right? So so we name that using the cast in language, all right? So the language that we are using is casting to the type of data, okay? With a strict type checking, right? So many times, if we are using this cast language, that could goes wrong, all right? So doing this kind of things not only result in program with type errors, but still worse, it may give to the programmer the idea, the feeling that his program is type safe, and in fact is not. All right, so so this is just a general idea. So this general idea of genetics to build up a method, or a class, or whatever, that could be, that we can use it for any kind of data is not something new. It was long time ago mentioned in functional languages like HOPE, for example, which allows the programmer to define so-called polymorphic function, right? So this is history in this moment. The solution adopted was based on the idea that the function should be abstract enough to be able to cope with any type of parameters matching this specified type, accepted by the compiler, actually. A different approach was taken in C++, where the notation of template was introduced, right? So we in C++, remember we discussed about template. Well, template are solving this problem in a different way. A template is a way to describe how how the compiler should generate the executable code for those parameters type which occur in the program being compiled. The difference between the two approaches is that in the functional, one result is one version of generic function emitted by the compiler, version which is abstract enough to deal with any kind of allowed parameters, whatever in the template. So in the template, we discuss about a different approach, all right? The compiler generates as many instances of the template as there are different, all right? So actually, all the compiler generates all the templates that could be applied to, to all the parameters, right? So that actually is not a bad idea. It's a very good idea because the template generated and eventually match the specific data. It's optimized for that specific data, right? For that particular parameter type. So this is great. Actually, it's an optimized solution. Well, the solution adopted in C# is somewhat between these two presented. In one hand, the object type is treated in the same way, all right? On the other hand, for each simple type called values in C#, the compiler will generate different code, all right? So the approach enable generated the both short, only on copy for each object type, and also, to make the compiling process more efficient. All right, one of the big advantages of generics are the performance, right? So, people, any questions? All right, so one of the biggest advantages of generics is performance. So guys, if you have any questions, please do not necessary to type it, to spend a lot of time typing. Just connect your microphone and ask me. It's not a problem. So April, so it's not necessary to, because I will post the document, okay, that will cover exactly this presentation, okay? So instead of having a huge record of the lecture, you will have the document, you will be able to read it directly, all right? Okay, all right, perfect. Right, one of the big advantages of generics is a performance. Using value types with non-generic connection classes result in boxing and unboxing when the value type is converted to a reference type, and vice versa. Value type are stored in the stack. Whatever reference type are stored on the head. C# classes are references type, and structures are value type. .NET make it easy to convert value type to reference type, so you can use a value type everywhere an object, but which is a reference type, is needed. For example, an integer can be assigned to an object. This conversion from a value type to a reference type is known as boxing. This process of boxing occurs automatically if a method requires an object as a parameters and the value type is passed. In the other direction, a boxed value type can be converted to a value type by using unboxing. Right? With unboxing, the cast operator is required. All right, so let's stop about discussion and let's run a small example. For example, the following shows array list class from the namespace system collection store object. Right. Let's see the example. Simple. The add method, right? So the add method is defined to require an object as a parameter. So an integer type is boxed. When the value from an array is read, unboxing occurs and the object is converted to an integer type. Right? This may be obvious with the cast operator, that it's used to assign the first element of the array list collection to a variable I1. But it also happens inside the for each statement when the variable I2, all right, of the type integer is accessed. Okay, so in general, boxing and unboxing are easy to be used, but have a big performance impact, especially when we are running iteration over a lot of items. All right, when we talk about a lot, doesn't mean million, right? We don't talk about tens or whatever, right? We talk about millions of items. Right? So this is a tricky thing. All right. Well, instead of using objects, list T class from the name system collection generics enable you to define the type when it's used. Take a look, the type when it's used. In the example here, the generic type of the list T class is defined as an integer. So the integer type is used inside the class that is generated dynamically by the just-in-time compiler. Right, and let's sample in the. All right, let's discuss now about defining generic types in C#. How we can define a type-safe generic implementation of a stack data structure. Okay? The specification of generic type requires special syntax. Right? So when I'm doing generic, I have to use a specific syntax with angle brackets for to show the parameter of the generic type. Right? So let's then I'll post it on the board now. So now we discuss about generic implementation, okay, of the stack. So, and this is the way how we live. We make the system to understand that we are working with generics. If you'll take a look a little bit up, you will see the similarity with the non-generic example, right? The difference is the fact that the type parameter given is given in angle brackets at the beginning of the class declaration, and the replacement of all occurrences of objects with the tip type of the tip T type parameter. Well, this is just syntax, right? But the semantic is totally different. Previously, we discussed about a stack of everything with no way to assure that our use is type safe. So the initial one, okay, we have a stack of everything, but it's not type safe. Now, in this condition for a generic implementation, the compiler is able to type check every use of the defined generic type and to find violation of the type system, right? So actually, in this condition, if we implement the generic, the compiler now it's able to check and to verify if there is any kind of violation of type system. The use of generics is very simple. You just have to state the type of object to be stored in our data structure, right? Okay, so now it's not possible to put by accident an integer into a stack of a person. What will happen is if one tried to use generics and the old way of declaring type of stack element is just object. We will be able to write something like that. Right? But, we can do it, but somehow this is not the proper way of programming. Okay, so, this way push us to a different problem. For example, how to specify a structure which should be used only for specific type of elements. All right, so now we understand that we can use generic for any kind of elements, for any type of elements, but there is a way to go back to use generics but for specific type of elements. All right, and the answer is yes, we can do that using constraint. Okay, so I will show you another very short example piece of code that let us consider a collection of persons. Okay, each person objects understand the message, what is your name? Okay, so this is a message. Using inheritance, we can create person hierarchically with the example children, student, employees, and even we can go deeper and we can specialize employees as clerk, worker, technical assistants, movie stars, so on and so on. Let us assume that in our application we want to define a collection of person, various kind of person, and we want the collection to be able to print to print names of all the person is contained. At the first sight, it looks like we can do it but actually is not like that. So let's show the class first. So we'll try to use it like this. Right? To insert a new element. Well, if you try to do it like that, class, class declaration will not compile. Why? Because the compiler doesn't know what my collection will be used only with person type parameters, and actually eventually with any subclass of person as a parameters, right? So so in this condition, the computer will reject the line system console write or write. So this line will be rejected. Right? So because simply the system will not be able to interpret what is your name of any value type C. Well, what is the problem? The problem is that this version, all right, it's also incorrect. All right, in this case, the compiler do not know how to convert a value of any type P into a person, right? Um, okay, so how we can solve that with generics? Well, we can do it by using constraint, all right? And the syntax of a constraint declaration involves the word where, right? That one is a keyword, all right? And how will declare? I will declare like that. All right, so let's forget about what we wrote before and we'll, okay, where T is a person, okay? Now, the previous piece of code will compile because now we know what is a T parameter, all right? Okay, so this where, which is a keyword, allow even more sophisticated constraint. So let's consider a class with two parameters, all right, something like that. So sure, we can specify that the first parameter must inherit for or implement the second. Inherit the second. Okay. All right. All right. So how we introduce race. Okay, so how we introduce constraint, we are using where clause. All right, so to introduce a constraint, we are introducing where clause. All right, that specify that a type of parameter it's a most, it's the it's at most as general as a type expression, right? It is not possible as to specify that is at least as general as a given type expression. All right. So generics. So we have now a general idea what are generics, right? And now we know that we can introduce constraint in a generic. Okay? So why we are using generics? So the most common use of generics is creating collection of various kind. All right. So this is what I'm using generics to create collections. Um, and C# provides the user with a rich set of generic collection. Let's name it lists, queues, stacks, dictionaries. All right. Of course, our previous example could be implemented easily with using the generics. So now we have an implementation. Now we have an implementation using generics, all right, and that will compile nicely, right? So that, let's name it, was again a very short presentation about generics, why we are using generics, why it's a good idea to use generics. All right. So first of all, help you by reducing the amount of code. Second, very important, is type safe. Okay. So actually, we should use generic in an extensive way. And let's have some examples about that. And it's very hard to talk about. All right. Well, starting next week, we'll go ahead. We'll start discussing about data structures that store and manipulate objects references. One problem of storing object references occur when retrieving. So when we are calling, data from a collection. So an application normally needs to process specific type of objects, right? So when we run directly the application and we call for the results, actually we discuss about specific type of objects, right? As a result, the object references obtained from a collection typically need to be downcast an appropriate type to allow the application to process the object correctly. All right. In addition, data of value type, integer or double, must be boxed to be manipulated with object references, which increase the overhead of process. All right. Most importantly, processing all data type limits the capability of the C# compiler to perform type checking. All right, so to make to check all the types and to have a type safe results. Right, so we'll go to the definition about generics. So generics refer to the technique of writing the code of a class without specifying the data type that the class work on. All right, you specify data type when you declare an instance of the generic class. This allows a generic class to be specialized for many different data types, only having to write the class once. So when we are using generics, we are using generics to maximize code reuse. All right, we know that generics are type safe, and we know that generics are high performance, is a high performance technique. The most common use of generics is to create collection classes. Okay. All right. .NET class library contains several generic collection classes in the system collection generics namespace. The generic collection should be used whatever possible instead of classes such as array list or array list from the system collection namespace. You also very important and very nice actually, you can create your own generic interfaces, classes, method, events, and delegate. Another very important aspect, generic classes may be constrained to enable access to method on particular data type. All right, and information about the data type that are used in a generic data type can be obtained as a runtime by using reflection. All right, let's run a short example because I talk a lot, and let's run directly. Let's so guys, do you have Visual Studio open? So all right, so
only 2017, but I should be able to keep up.
yes, because my examples are on console, and I make them functional on any kind of Visual Studio. All right, so let's I will post the code. Let me know if you are able to see the code. All right, so this is a basic implementation of an overload method. Okay? What I'm doing here, All right, so what I'm doing here, so guys, are you able to see the code? All right, so take a look. I'm not using genetics, right? Do you remember we discussed we are using just a system, basic system. All right, we create some arrays of integer, double characters, and we call them. All right, and what we have to do, we have to build up the method 3 times for different kind of, all right, for different kind of type, for different type of data, right? Okay, so did you run it? All right, so now we declare different elements, different type of data, and we call. No, we call them. All right, in the moment when you call, what the compiler is doing is trying to identify, all right, um, um, a method declaration that has the same method name and parameter, right, that match the argument type. Okay, so take a look in array, right? Okay, so that makes now um, to make this program, this small program functional, what I have to do, I have to build the method multiple times, actually 3 times, okay, because otherwise I will not be able to I will not be able um, um, to display all my arrays. This is a very simple, a very simple overloaded method, right? Because I'm using the same name um, for the method. Okay, so did you run it, guys? Did you build it? All right, let's try to build that using genetics. Guys, did you finish the first one? Okay.
Yes, Professor.
Yeah, so it's simple, right? It's a very simple one, all right? We just have. All right, so let's check generic. Right, so what I did, I write the method only one time.
Professor.
Yes, I'm sorry. I'm sorry. My microphone was off. I'm sorry.
No problem.
Yes.
So I understand the point of generics taking three methods down to one, but I mean,
Right.
surely in the day that we live in, three methods compared to one doesn't really make a difference. This kind of really has to scale up on a bigger, much bigger scale, right?
Oh, sure, sure, sure,
Make
sure,
a
sure,
difference.
sure, sure. It's now we are running just simple, very simple, very simple exercises to understand the idea of generics, right? So this is
And you're gonna post this code for us, just double checking.
yeah. So anyway, if you are not able to, to run it correctly or whatever, I will post it online, and you will be able to, and um, because the code is running, and you'll be able to check it again. All right. All right. So everyone is okay. So actually, by declaring display array as a generic method, we eliminate the need for the overloaded method, and we save, let's name it, a lot of line of code, right? And most important, we create a reusable method that can output um, the string representation of the elements in any one-dimensional array, right? Not in any kind of one-dimensional array, not just integer or double of characters, all right? All right. Now let's run something to show how we can use constraint, all right? Type constraint. Okay, so there are some elements that you should understand. So we'll run a short exercise that determine as and return the largest of three arguments, right? All of them of the same type. Well, when we compare values to determine which one is better, we'll use the operator, right? Bigger operator. Whatever, this operator is not overloaded for use with any kind of type that is built in the framework class library. So this is the reason that generic code is restricted to perform only operations that are guaranteed to work for every possible type. For example, if I have an expression like, let's name it, right, variable 1 smaller than variable 2, so this kind of expression is not allowed unless the compiler can ensure that the operator that the operator bigger, so that this operator is provided for every type that we call, or for every type of variable. Okay, so this is the reason that in generics, all right, we use an interface, e-comparable interface. All right. So what we are using in generics, we are using e-comparable, right, which is an interface, and allow us to compare to objects of the same type if that type implements a generic interface e-comparable T of the namespace system. So a very important thing, so why it's a good idea to use e-comparable T. So a benefit of implementing interface e-comparable T is that this interface can be used with the sorting and searching methods in system collection generic namespace. Right, so I'm using it e-comparable to sort and search. All right, guys, regarding question number 3. All right, question number 3 from your, question number 3 from your lab that should be ready in 2 weeks. All right, there is another method, compare to. All right, that method returns 0 if the objects are equal, negative integer if the object 1 is less than object 2, or a positive integer if the object 1 is greater than object 2. All right, so we have three exits. It is the responsibility of the programmer to declare a type that implement e comparable to and to use wisely e comparable to and the method compare to. And to understand what kind of object is returned. All right, so this is the idea. All right, so let's post the example. Guys, this example maximum will help you on your question number 3. Okay. All right, so guys, did you run the code? Guys, did you run the code? Okay, all right, I'm sorry.
I actually have an error when I'm opening this code example.
For maximum test?
Yeah.
Right. So
under maximum test.
let me. Let me. No, should works. Um, guys, it's a good idea when we are at the beginning of the course, right? So it's a good idea to test your Visual Studio if they are able to run. Maybe you need to update a little bit your tools. See what's going on.
Is it possible that's why I'm receiving an error, Professor? On my first two console.write lines, it says the type int must be a reference type in order to use it as a parameter. Because I see that's not the case in your code.
Yeah. Okay, so. Um, post it, please, on the chat. The error. Can you copy the error? Copy and paste.
No, give me a sec.
Yeah.
So I just have the error for the first two times it calls maximum, not on the third time it calls maximum. I will download Visual Studio as the latest one just to make sure.
So what version are you running?
2017.
17, right? Representative to use a parameter. Yeah. So looks like is. I don't remember what implementation they have in 2017. Let me check something. Not here. Not here. So. What I want, what I need, I need this. Ashley, use on the top using system collection generic. Maybe it was a separate implementation because now it's on the system. Maybe at that moment it was in system collection generic, right?
I'm trying that now.
Yeah, yeah, I know, but he had an old implementation, 2017.
No, that doesn't fix.
The same problem, right?
Yeah, it's grayed out. Using directive is unnecessary, so it's not even
Right.
using
So actually, doesn't.
What I do think is maybe the issue is where I declare my maximum class, I have to use the where parameter. Let me try this. But it's fine. I've downloaded 2020. I'll have the
Yeah,
latest
we have
version
to
installed
install
from
it.
the
Yeah,
start.
so
I
that
think we
is
should just continue.
Constraint. So I'm absolutely sure my code is working. So Ashley, I'm absolutely sure my code is working for 2019 version and up, 2021 or whatever. Okay, so starting with 19, it's working perfectly.
Yeah, I was supposed to upgrade to 2019 in the previous programming too, but 2017 worked. I see. It's catching up to me. I'll have the latest one installed. You can carry on with the next.
Yeah.
The teaching.
All right. Okay. So yeah. So guys, actually, it's not too much it's not too much to talk about. Anyway, this example, this very simple example, I will post them on eCentennial. Eventually, you can copy the code directly from here. What I want to make you aware eventually, the best possible documentation that we can get regarding C# in general and regarding our course in particular is from Microsoft. All right, so oops, just give me 1 sec because I did a boo-boo here. Let me do it in a different way. Yeah. And what I'm doing. All right, so so guys, here you have so this is So this is system collection generic namespace. All right. So here you have everything that you need. You have classes, structures, interfaces, so on, so on. Okay. So actually, this is what we'll discuss in the next actually 3 weeks. Okay. So please take a look. So you have here a lot of examples, right? So you have definition, you have examples, you have now some remarks regarding the example. So please take a look to to Microsoft documentation. It's very important. Okay, I'm not asking you to remember. I'm not asking you to memorize anything from here, right? Just to know that all these methods exist. So you have a lot of things: constructors, methods, interfaces, extension method. Take a look. Only here, extension method. All right, there are tons, right? We'll not put them in our lecture, in our course. Give you just basic information: what is a generic, what is a kind of data structure that we are using with generics, so on and so on. Okay, and everything else you can update yourself using the Microsoft documentation, which is actually the best, right? Because it's a C#, is supported by Microsoft. So my advice for next week is to go quickly over the theory regarding generics, especially for people that never heard about generics. All right, to understand the idea of generics. And guys, very important, incredibly important, start working on lab number 1. Okay, so this is really important. All right, so you have here lab number 1, generics and the extension methods. Start working on exercises. Okay, guys, if you have any question. So due date for that is, if you will take a look here on the calendar, take a look, January 28th. All right, end of the day. Okay, this is a due date for your submission. Questions, if you have questions. All right, so guys, if you don't have any questions, I'm wishing you a very nice weekend, a very nice week ahead. Again, please start working. All right, please start working on the lab. Take a look to the programs. Run as much example as you can. All right, don't forget what you have to do, where we can find examples. You can find on Nijo, okay, on the book. You can find on Microsoft documentation. You can run the example that I would post them on eCentennial. Okay, try to understand, eventually working groups if you have problems. Okay, build up groups, small groups, and work together and build up the homework. Okay. All right. So again, any question, any problem, you too, Abby. Thank you so much. So guys, any question, any problem, let me know. All right. So you have my email address. Eventually, you can ask me during the lab hour. All right. And see you next week. Okay. Don't forget to stay safe.
Have a good evening, Professor.
Thanks so much, guys.